Hello, this is Ethan, Interactive Advanced Concept Presentation 8. We're going to jump right into the experiment here. And this is going to be, we're talking about phase change. So here we have some super cooled water. I'm going to try to rub off a little bit just so you can see it's clear water. And I'm going to deliver a blow and see if we can get it to nucleate, or nucleation, so nucleate. No, we can't. Okay, let's try a different one. This is another bottle. You can see it is just water here. Try one. Honestly, I'm just going to put them back in the fridge at this point. Uh-oh. No, okay. You can see this one actually does have a little bit of ice in it now. I think we were just not really cold enough. So I'm going to take this one. We're going to try part 2. We have some ice here. So I'm going to open this up and pour it on the ice and see if we can get any ice to form. No, we can't. Maybe if we try with this one that might have been a little bit colder. No. All right, well, that's 1 for 2, I guess. I have one last bottle here. I'm going to grab a piece of ice real fast. All right. So I have one last piece of water. I'm going to add it to this bottle and see if we can get the bottle to freeze. I'll hold it up here for you so you can see. No, I can see really small amount of crystals forming in there. It's really difficult to tell through the camera. But there are a few ice crystals forming. I don't know if you can see them or not. Very minimal amount. Well, that's unfortunate. So I guess we will just discuss what may have went wrong here. You can see this one's kind of icy now. This was the one that I hit in the beginning. The one that we poured onto ice, we couldn't really get it to form little ice blocks. Maybe if we try this one. No. Maybe if we try this one. No, I'm really trying here. Okay, yeah, so no go on this. I let them sit for about 2 hours just because they were a lot smaller than your regular 16-ounce bottle. These are only 8 ounces here. So I'll just talk about what the procedure kind of was, what the idea of it was as well. And then I'll kind of talk about why maybe ours didn't work. I had about 6 of these in my freezer just to be able to kind of test them. And I had 2 that froze when I hit them. I don't know why these ones weren't as cold, but so this Interactive Advanced Concept Presentation 8, what are we talking about? We're trying to flash freeze water, which the one that I hit, like I said, it had a little bit of freezing in there. I don't know if you can still see some of the ice crystals floating around. And what's happening is it's a phase change. So I made a little diagram here for you about phase change. On our vertical axis, we have temperature. Horizontal axis, we have energy. From the bottom up, you can see this first ramp is solid, second ramp is liquid, third ramp is gas, The flat lines there are our transition, our phase change there. So coming from here this way, from liquid to solid, we have freezing. Solid to liquid, we have melting. Liquid to gas, we have evaporation. Gas to liquid, we have condensation. In our bottles, we're supposed to be about right there, which is in a state, a super cooled state. So it's called super cooling a liquid, which is bringing that liquid below its freezing temperature without it actually transitioning to that solid phase. So then we have nucleation, which I kind of talked about a little bit. What nucleation is you have this still form of pure water that is supercooled, and it's in stable clusters of H2O molecules. So while it has the potential to become a solid, it's not, it's undisturbed, it's totally pure, it's not transitioning to that state considering how slowed down it is, it doesn't have a whole lot of movement, so it's not really putting itself into the position to form the crystalline structure that we know of as ice. So hitting it is allowing for the aggregation, so you're disrupting it and then allowing for aggregation of the H2O molecules by introducing at least, one crystalline formation. So then they all kind of pack onto it and you see that ripple effect spread throughout the bottle. Introducing the ice, how I dropped the piece of ice in here, you could see a few little spots where there was some freezing, but not much. But you're just introducing the nucleus, which is the ice, it's the already created crystalline structure, introducing it to the water that should be below its freezing point, and then all those H2O molecules will kind of pack onto that ice and you'll see that ripple effect once again. Pouring this onto ice, you're just introducing this to the nucleus. So we have creating a nucleus, introducing a nucleus, and adding to a nucleus. And so what should have happened there is you pour the water on and it kind of grows as ice on top of that nucleus. So what kind of went wrong here? I think that our water wasn't cold enough. Like I said, I had 6 of these little bottles in my freezer. I did 2 of them that I hit and they formed ice. So I figured these would be cold enough. I gave them about another 15 minutes, but apparently not. So that's one thing that went wrong. Another thing that could have gone wrong is the piece of ice that I put in here was relatively small. So maybe it's just not enough ice. But really it's just that the water wasn't cold enough. So, but that's week 8 interactive advanced concept presentation. Sorry I couldn't give you a cooler visual. No pun intended. Thank you.